Hi guys, welcome to another video. Today we'll be doing the LeetCode Daily challenge of 9th July. So the question is average waiting time. Um, I've gone through the question. So basically, um, yeah, we are given a 2D array of customers where the first element is the arrival time of that customer, and second is the time that this customer's order will take to prepare. Okay, and whenever a customer arrives, he gives the order to his chef. Uh, there is only one chef. Uh, Orders are prepared in order that customers arrive. Mhm. Customer waits and the chef does not prepare the food for more than one customer at a time. Prepare food for on the when they given the input. Customer will order that the given in the input. 1 second. So this says the prepares in the. So do we know that the customers are given in the order of their arrival time, average waiting time we need to find? The actual answer are accepted. 10 to power minus 5 to okay fifth decimal. 5, 5, 10, 20. I'm guessing they come in the increasing order of arrival time. Um, okay, so this one comes at 5. This one also comes at 5. This one comes at 20 and this one comes at 20. Sorry, 10 and then 20. Okay. So basically, yeah. So at every point of time, some customer can come and they'll be ordered. So they'll be ranked in their arrival time. But if two customers have the same arrival time, the customer whose cooking time is less, I think that customer should be given a priority because let's say the other one has to wait, right? The first one will be processed, second one has to wait. It is better that he waits less because our answer has to be the average waiting time of all customers. Oh, we don't need to order them, we just need to wait a second, we just need to give the average time. We don't need to optimize anything, we just need to find the average time every customer has to wait. Okay, so minimum every customer has to wait is the preparation time of their own order, correct? So how do we approach this? So this first customer, chef would be free, um, and the order will take 2 units. So time is, let's say 5, we start at 5 and this chef becomes free at 7. Okay, next, let's say we can have a next free counter. Next free would be 5 plus 2 7, right? And then this customer has waited for 2 seconds. Now the next customer, this one, he'll have to wait till the next free time, which is again 7 minus 5 2 plus the waiting time plus the order preparation time of this customer. So 7 minus 5 2 plus 4, I believe. Oh, it is 6. The second customer arrived at 5, but the chef takes his order at 7 and finishes at time 11. Oh, right. So 7 minus 5 is 2. 2 plus 7 plus 4. 11. 11 minus 5 again is 1 second. So we start at 5 2. The next free time is at 7. At 7, the uh, chef becomes free and his order, this guy's order is ready at 7 plus 4 11. So 11 minus 5 is 6. Now this chef is free at 11. 11 plus 3 would be 14. 14 plus 1 would be 15. Okay, 14. Now for this one, chef is already free. Oh, it is directly the sum of these. If the chef is yeah, I think the question is not as complicated as it looks. If chef is free, waiting time equals uh, prep time of the customer. Else, if the chef is not free, else what is the waiting time? Waiting time would be um, time when chef would be free plus okay, plus prep time minus arrival time. Okay, let's give it a shot. So we firstly want the sum, or it is in double. So let's keep double only. Double total waiting time equals 0. Mm, and next free. So next free is denotes when chef would be free next. Okay, so let's iterate through the uh, customers array and customer. This belongs to customers. Now there's two scenarios, right? If okay, sorry, if next free is less than or equal to let me put this in another variable, int arrival equals to customer 0 and int prep time equals to customer 1. Hmm. Okay, so if the next free, whenever the chef is going to be free, that time is less than or equal to my arrival. In that case, my total waiting time would simply increase by the time this guy's order is going to take. Else, um, else what is going to happen is I'll first have to wait till the chef becomes free. Okay, and just a second. Trying to see if there can be some optimization. So let's say the chef was free here at 14. Till 20 he had to wait anyway, and then he did. Uh, so how do we update this time, right? Let me put that logic inside. Okay, I need to put the logic of updating the next free in this case. Else what? Okay, else what we do is just a second. So if the chef is already free when this customer has arrived, that means the waiting time for this customer is the prep time that is needed, and my next free would become next free would become so we can't use the old next free because like in this case it was 14 first, and then it became 20, and then it reached to 21, so equals to my arrival plus prep time. Okay, and in this case think time okay, something would increase. How much time will we need? So this is the case where let's say uh, next free was 7, and arrival was 5, and prep was 4. So whenever the chef becomes free, he's going to take up this order. So next free plus this order is going to be the final time. Uh, so next free plus equals to prep time. This is going to be the final time. Now next free minus this guy's arrival would be the time that this guy waited. Okay, and next free has been updated. Right. Next free 7 plus 4 is what, 11. Next free becomes 11. 11 minus 5 is this one. Now, in the next case here, we're at 11. Again, we'll come in this case. 11 plus 3 is 14. Next free becomes 14, and 14 minus 10 is 4. Now, in this case, since 14 is less than equals to arrival time, my total waiting time plus equals to the time this guy waits is for his own order. So that is the prep time, and the next free would become the arrival time plus prep time. Okay, so we'll need to return whatever my total waiting time was, just divided by number of customers. So customers dot length. Yep. Okay. All is a mess. Interesting. Custom is this customers? Oh yeah. Waiting time divided by customers total. Cool. Now this is fine. I'm just thinking, is there any like I have a feeling that so yeah, based on the question, it feels like we need to optimize something, but we don't need to optimize anything. We just need to return the average waiting time for all. That is all we need to do. So mm, this time we didn't start. Oh, nice. Oh, this was a bit straightforward. Let's see. Yeah, so I hope you understood that this question, we didn't need to optimize anything or try to fit the customer with the least waiting time first or whatever. Nothing of that sort. We just need to process the customers in the order that they have arrived. So this order, it stays fixed. It is the correct order. There's no need to change this order. Every time a customer arrives, he's at least going to wait for the prep time of his own order. So this is the least amount, firstly. Now, if the chef is not free when he arrives, he'll wait that additional time till the chef becomes free. So this is the first case, and this is the second case where he needs to wait. Firstly, he needs to wait till the time the chef becomes free, and then additionally he needs to wait for his own prep time also. Got it? And accordingly, we update the next free as well. So yeah, that's all for today. I'm going to open a solution and see if there's any better solution available. Just any random solution, uh, just to see if I miss something. I feel this is everything, but yeah, no harm in the same thing. There's just this logic is a bit simple to understand. If this, otherwise this. Okay, do we have a better solution? Three stuff it seems. Yeah, same thing. So yeah, you might find the solution somewhere. You'd feel like doing this, so doing something like this, or you might feel this is better. We don't have any if else clause. But the thing is, what works best is what is clear in your mind. So I understand that there is some common thing between these two cases, and we could simply like put one if flaws and do this. I totally understand that, but what we're doing here is sort of having a very clear approach that either this happens or that happens. So there's a little less chance for confusion in this question. I don't think there's much difference, but in future, uh, in the beginning, even I thought of putting some common statement up here that would help in both the cases. I still can do that, but I feel if we can segregate the logic, and if we, the logic is segregated in our mind, it is easier for to debug later or to move on to much complex questions. But yeah, feel free to do something like this as well. Uh, yeah. Also, this double, we don't need to do this here since the total waiting time was declared as a double. We don't. So the division would result in a double itself. There's no need to explicitly typecast. Yeah, that's all. Cool. Thanks, guys. See you in the next one.